Welcome to another episode. In this episode we are going to use some threaded bars, some nuts, scrap and some bearings to try to build a Unimog cab tilt mechanism so we can tilt the cab on the truck. But we'll probably need something a bit sturdier than this. How about that? What do you think? Nah. Let's use this. Nuts like this. These are M30 nuts and bolts. Let's see what we can do. Before we get started with all of this, it's very important that you understand that this is for entertainment purposes only. I'm not an engineer, this is not an engineering drawing, this is not certified, this might be very dangerous. I do not want you to become a human waffle in a Unimog waffle maker. This might hurt you badly. Don't do this. If you do go ahead with this, then please make sure that you're safe. Do your own calculations, do your own maths, do your own safety precautions and all of that stuff. So, basically, I'm an idiot. Don't do this. There's a few reasons why you'd want to tilt the cab on a Unimog. Most of them are to do with convenience rather than necessity. I've been told that the only real reasons why you need to tilt the cab on the Unimog SBU is that you need to access or change the engine. In our case, we simply want to access under there because we are a bit convenient and lazy, and I think there's a lot of space under there that could be repurposed, and it's very difficult to do it from the underside. Besides, I hate crawling under vehicles. The primary reasons why we actually need the cab tilted is because we're going to build the box in situ. That means that we need to put cladding on the box, and the minimum clearance between the cab and whatever you put behind the cab is 70 millimeters. I am not that chunky, a bit chunky, but not 70 millimeters. So we need to be able to access that area anyway. If you consult the almighty oracle of Google or similar search engines on the interweb nets, there are several homemade versions of a cab tilt for the Unimog. Some people build an A-frame and just lift it using one of those chain thingies. Some people use a forklift. There are many variants. However, there seems to be a few people who have made a variant that uses threaded bars, or all thread as it's also known as. I have seen a few pictures and I have seen a few drawings and a lot of discussions about these things. The Mercedes solution to this is a hydraulic pump, and I have seen those very rarely come up for sale at some astronomical sums. Let's just say that we would never be able to buy that. The cab tilt that we are going to make is an evolution of what's been found on the internet, and primarily by a gentleman named Kieran Greenan. He built one and he actually made a drawing. And I have studied the drawing, and thanks to Kieran I have also got a few videos and a little bit of other help where my brain wasn't simply capable of understanding what was going on. Therefore, a huge thanks to Kieran and everybody else who've built these things, shared them on the internet. My aim with this video is to share my experience and my knowledge to further this cab tilt concept. And I hope it might be useful to someone and that you can build it, but don't get hurt. I spent a long time trying to figure out where all the parts go and how this actually works. And I've come to the conclusion that this bit, the one that goes on the bottom is quite simple. This rod is a rod that's going to be attached to the chassis. This rod is the rod that's going to be attached to the cab. When this rod turns, then these nuts will slide up and down just like a regular Boltimer thing. This part, the bolt will turn, but this won't. So these will stay in place. This one welded to this rod, sandwiched with a bearing, and then there's going to be a plate that holds these together, and then there's going to be another bearing, and then an adjuster nut, and then a squish nut, and then a bolt through this to prevent it from falling off. On this side, these are going to be welded to this tube and then sandwiched in between the plates that go on there. That means that this one will be moving just like a regular bolt in and out of here, like that. And then the more complicated bit is up here. So let me move you into there and you can have a look at that. The part that connects to the cab is a little bit more complicated than the other bits and pieces here. The drawing has got a simpler way of doing it, but for some reason I feel the need to complicate it. That works just fine. You can build that. What I'm planning on doing is I'm planning on using the rod obviously to go up and downy. Then I'm going to weld this bolt onto the rod. I have a bearing here, and then I'm going to put a plate in here, and it's going to be sandwiched between these two bearings. And then I have a bolt to adjust and a bolt to squish that bolt tight, and then I'll probably end up adding a bolt through the bolt to make sure that these nuts can't come off. That gives me a plate here that doesn't rotate with the bolt, the big bolt, and on the bottom of this one I'm going to have two holes, one on each side, and I'm going to screw M10s into these connection nuts, which will then connect to an eyelet up here, which will connect to the cab, and this bolt will then secure that eyelet to the cab's eyelets. I don't know if that makes any sense, but if it does, good. You're better than me. It took me a long time to figure it out. So anyway, this job. I'm just gonna start making stuff, and hopefully I can explain as I go along, and hopefully it'll all become clear and it'll actually work, because I have no idea what I'm doing. So I'm sure it'll be fine.
The first step is to clean up these pipes. I think they're old water pipes, so they're covered in paint, zinc and whatever else they thought was a good idea whenever they were made. Once the pipes are clean, it's time to scribe the plate with the holes and all that. What's important here is that the holes, and thus the rods, are far enough apart so that we can get a big tool in there between the legs, the rods. But on the other side, the further apart they are, the larger the skewing forces are going to be. Next is the drilling. I drill the pilot hole first, and I open it up to just smaller than the center drill on the hole saw. I find that the hole saw wanders quite a bit before it gets into its own groove to cut into. Keep removing the chips as much as you can, because when the gaps between the teeth in the hole saw gets filled, it stops cutting, and all you do is generate heat due to metal on metal friction. This ultimately destroys your hole saw. Then it's the long-winded task of cutting the plates out and shaping them. I wish I had a bigger cutting disc, or even better, a plasma cutter would have done a fantastic job here. Using the angle grinder with the cutting disc or grinding disc is a dirty job. To get comfortable, I don my face mask, goggles and stick my Bluetooth noise isolating earbuds in, play a podcast or audiobook and have at it. It makes it a lot more pleasurable, but it's still a dirty job that's got to be done. Finally, I take the plates to the disc sander and give them that nice edge. In hindsight, I should have spent a little bit more time with the disc sander, as I should have made the sides more parallel. Oh well.
I have now prepared the parts for the central bit, the two that connects the two threaded bars. That means I have two tubes. I have two nuts, go like that, and my OCD had to take the nut, the hexagonal nut bits off, because they shouldn't be there unless you use a spanner on it, and these are going to be welded, so no point. Then I have two flanges. They look like knuckle dusters for two-fingered gigantic people, and those bits are now going to somehow make the connection rod. So I'm going to lay it out on the welding table, and I have a video about this welding table. Sorry, I'm lying. I have 4 long videos about how to make this highly adjustable folding welding table. I've screwed on the artist formerly known as nuts, and I put the tube in between here. I want to tack this first to make sure that it actually spins. The galvanized coating on the threaded bars and the inside of the nuts seem a bit rough, so it's quite a lot of work to run the nuts up and down. The setup is quite simple. I put a regular nut at the end there to make sure that it's sort of parallel and these aren't on the ground, and anyway, I'll just tack it in and see where we go from there. Well, the first welded on nut didn't succeed. I just didn't get enough penetration. So it just cracked. So I tried again. It's close to 7:30 and it's time to give up for today. It's not probably a surprise that today didn't go as well as I had hoped. But this is a learning exercise. I managed to get the parts for the center bit cut and done, as you saw, but I didn't manage to do enough welding. The major thing that's taken a lot of time is that I didn't really realize how tight and bad the threads are with the zinc coating. Now when I look at it, yes, you can see there's tons of zinc everywhere, and they're not very smooth, and having one nut on that has been broken in is okay, but it needs a lot of effort, as you saw, jogging the nut back and forth on the threaded bar. which kind of means that I have now regretted putting the first bit on and tacked that, because I don't think I can now get that through without a lot of effort. So I don't really know where to start tomorrow or whenever I get to work on it, but I do know that I am looking for some hardship there. I have it in the welding position now, which means that I can focus on aligning the two bars, and hopefully I can tack this. And when it's tacked, I can hopefully unscrew this bar and then run it through the breaking in process, and hopefully that will then make this actually work a little bit. But yeah, that has taken a lot of time. So if you're one of the guys who work regularly with M30 and you're now sitting and laughing, that one's on me. I have never worked with M30 before. So I'm now going to go inside and see if I can gather some energy for tomorrow. As you recall from a few seconds back, this is where we left it yesterday. In my world, it's about 12 hours or so since I was here mucking about with this. One of my things I would have done today is that I would have edited this, but instead this has been bugging me, so I had to come out here and see what I can do. What bugs me is obviously that I have these two X nuts here that are still nuts on one side but not on the outside, and they are tacked in here on a rod that has got a lot of stick to it. So it's a stick with stick. But I can't get it off easily. As far as I can see, the only way for me to get this bit off and then do the thread thingy, breaking the threads in on this one, is to weld this onto these bits, so I have something to clamp onto. And then I can use two nuts on this one and hopefully I can pull it out, and then I can weld the end nut onto it, and then I can do that whole back and forth thing to get this one to run nicely in there. So yeah, it's been bugging me and I need to sort of solve this before I can get some form of peace of mind with this. So yeah, without too much faffing about and talking, let's see how many more mistakes we can do today. As you can see, I got the stick out. It wasn't that sticky or brown. Anyway, yeah, I tacked it 4 places on each of those, and I clamped this, which means that the center tube here holding this rod is not attached welded yet, which is good. I want to keep it as flexible as possible, but right now I'm going to weld the end nut onto the other rod, the one that was in here, so I can then break it in, make it a bit smooth. Yeah, okay, yeah, this is a good workout for a unfit old geezer like me. As you can see, this surface isn't very good for welding on. So the first thing I'm going to do is to grind this one flat and get rid of the dirt and the zinc and the paint and whatever's on there. And then we need to make sure the nut fits in the nut. It's just about. All that's needed is to get some material off the tips there. Just a tiny bit of the, now with a bit of luck, goes in there. And now we can use this to center this and all that sort of stuff. I'll thread the nut on the here, and then I can put this into there. Now I can scratch the hole there so I know where I can put the initial welds on there. So now I have a scratch mark on there which shows me where I should put some weld on before I put the nut on and weld the inside of the nut. But first let's use the step drill to drill a little bit away of the threads here. Hold the nut with the Vice Grip Garage favorite tool. Bug there, dead. Spray it with lube. Now there's almost no threads in there, which means that it should be bare metal, and a molten MIG wire should stick there a little bit better than with just the threads in there. But also let's get rid of the zinc on the faces too. That'll do. Don't forget to clean the oil off the. Okay, so here we have it, ready to weld, I think. I've added some weld in there now. I filed off some of the spatter that was around it. Now I can put the nut in here and I can check that it sits parallel with this nut, which means that it should be in a pretty good spot. So now let's blast it with as much heat as we can, and don't breathe in the zinc vapors that are coming up from this. The little nut is now welded on in there, so I need to remove the big nut, and then I'm going to go and grind some of this bar off. Basically I'm going to extend that nut down, and then I'm going to cut the groove around it so I can add more weld to the groove and therefore have extra much fusion between the nut and the threaded bar. And as you can see, here's the nut welded on, and this is the threaded bar there, and then I cut a groove in between, and I'm now going to fill that groove with weld so that we get extra much adhesion between the threaded bar and the nut. And there you have it. Some hot metal glue squirted into the groove there. I'm now gonna grind it down and make sure that the socket fits over it. Here's now the combined nut and bar thingy, and the socket fits on there. And judging by this one that's here, which is just outside the frame, I think, this will take a lot of abuse. You could obviously do this without the nut, but I find the nut being very helpful here to guide where I grind off onto the threaded bar. If you have a milling machine, you could obviously machine this flat. If you are like the guy in Click Spring, then you can obviously file this down by hand and you get an even better fit. Now I just need to break this bar in with the nuts and stuffs. Yeah, let's get a bit sweaty. I've now jogged this bar in and out more than I care to remember. It's still not as loose as I would like it to be, but it sort of can be done, which is enough for now. I'm gonna do some measurements and make sure that this is where it sort of should be. I'm gonna tack it probably and then take it off and see that it's sort of in the right place. That's the next thing to do. Organic engineering, right?
I'm spending quite a lot of time here trying to clamp it all down in a good way, aligned properly, parallel, not binding and all that. I then try really hard not to put too much heat into the piece, and I try to spread my welds around. But still, binding AF. And AF stands for absolutely fabulous, darling. And then after the welding, I try to take the rods out, and yeah. Well, at least I got a good exercise.
With this connector piece now fully welded, I'm going to add these braces in here. It's probably overkill, but I just want to make sure that the compression, which is going to go from that side to that side, is not just on these plates, so that there's a little bit of cross bracing here to make sure that we have a little bit more strength. Probably overkill, but anyway, so I'm gonna buzz these in now, and then I guess it's enough for today. It's now a few days since I worked on this thingy last, and it's been bugging me that it's been binding so much. That's the nuts in there, and they are not good. I can't spend that much energy on turning the rod when there's going to be compression from the cab on it, on top of that. So I now want to find out how much twisting force it takes to actually turn the rod in there. So I'm going to put the rod back in, and then I'm going to use this device. This is a torque wrench kind of thing, where you put your socket on there and your twisty thing in there, and then it'll tell you in a digital way there with electric fairies and stuff like that in there to figure things out, how much torque it takes to actually turn this thing. I think the binding isn't that bad, you know, it just needs to bind a little bit for it to feel a lot. Does that make sense? Part of me goes in my head and goes, I should have followed the drawing, I shouldn't have welded them in, and yeah, you were right, yeah, you were right. But let's try to fix this instead of playing the blame game here. Well, after that little workout, we have established that it binds. That's not good. Anyway, I think I have an idea on what to do with fixing the threads, or making them a little bit looser. As it happens, I have a third M30 threaded bar, or all thread. Let's see what we can come up with this one. I have no idea if this is going to work, but what I've done is I have cut some grooves at the end of this one. and hopefully that will act as a makeshift tap. If I now force it in there, maybe it'll work better. Let's do some workout. I think I have to admit that the efforts haven't been as fruitful as I had hoped. I'm going to show you now the difference between the first attempt this morning and the one right now. So, a little bit better.
At this stage I'm starting to get a bit desperate. This whole thingamajig is depending on that these two rods can be turned fairly freely. I feel like I've screwed it up. I also know that the physical binding is small but the effect is large. I'm trying all sorts of methods. I run a triangular file in the grooves of the thread, but the file just gums up with zinc. We discuss, we talk, we debate, we try.
I guess today's trials and tribulations and the input effort hasn't really matched the expected output. As you've seen in the footage, I have tried to use the tap, a homemade tap, to fix this. That didn't work. Then I tried to use a file on the threaded bar to make the threaded bar a little bit smaller and therefore give it a little bit more wiggle room in between the nuts. And that didn't really yield any results either. However, what did yield results is cutting the tube right here. This cut is now bigger than what it was when I cut it, meaning that this bit needed to go that way a bit, and this cut is smaller. And now the rod turns with about 10 Newton meters compared to over 100 up to 150 Newton meters earlier. So yeah, that's a result, even though the way I got to it wasn't how I wanted. So now I have two gaps here that I don't really know what to do with yet. I might just weld a piece of flat bar across here and maybe tack it to that one. That should be enough. Maybe I'll take the whole thing off and come up with something else. I don't know. But I think we'll leave it for now and we'll progress with other things, and then we will revisit this with a clearer head and a better perspective. Yeah, not the best day. With this, cutting the tube and adjusting the binding and working on that now being ignored, close your eyes, fingers in your ears, shouting la 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 la, I'm going to move on towards the chassis mount. And in theory this is a simple thing. There needs to be something that slides up and down on this rod, and then there needs to be a 20mm hole, or was it 25mm hole that attaches to the chassis, to the sticky out bit there. Now I was going to take these two nuts and weld them together. Do you hear that warning sound? Probably best to ignore it. Anyway, yeah, that's sort of the idea. I don't know if it's going to work or not, but that's what I'm going to try to do today. The design of the chassis mount is in theory very simple. 2 nuts need to slide on the threaded bar, and then we need to make an ear, a tab, that attaches to the chassis in a perpendicular fashion. I have this piece of flat bar, it's 10mm, it's what we used to do the end pieces, but that's all I have. The good thing with this one is that it is pretty uniform in thickness. I also have offcuts from this 10 by 10 centimeter angle iron that I used to build my sheet metal bender. If you want to see that video, let me know and I'll start editing it. Anyway, and here's one offcut. So this used to be a sticky out bit there, kind of like that. Now the problem with this one is that this is not uniform thickness, but it is scrap, and I do have pieces, and maybe I could make use of this flange if I made one sitting like that. So I think I'm going to try to use this piece, because they don't need to be, the sides do not need to be parallel. The hole just needs to be pretty straight, and even if it's not straight, there are these nuts that can actually wiggle around. So let's mark it out and see where we end up, as usual.
Whilst we're watching this time lapse, I'd like to thank you for coming along for the ride and wish all the new subscribers a warm welcome. If you haven't already, we're on Facebook and Instagram. Check out the links in the description. We put extra info in there, including links to various resources and products. We really appreciate your support, and we do our best we can to answer your questions you post in the comments. So if something's unclear or you just want to give us a moral boost, please go for it. If you find these videos useful or entertaining and you're in a position to support us through PayPal or Patreon, that'd be fantastic. No pressure though, we understand. So thank you again for coming along.
The 2 X-angle iron pieces are tucked together, as you've seen, and I have now drilled a 6mm hole. The pilot drill for the hole saw is just a little bit bigger than that, so I can push that in there. But before I do the hole sawing on the actual piece, I have used the hole saw on another piece, so I'm now going to go check on the Unimog to make sure that it actually fits, because I don't want to come with like a couple mil undersize or something like that and then have a trouble boring it out. This here is the chassis mount, and this here is the test piece. Ta-da! That seems to work. Tickety-boo! And now that we know that the test piece fits, let's make a similar hole in this piece. So now when we have the hole, let's see if it fits on the truck. Yes, it does. Let's also see if the bolt fits through. Yeah, that one's a bit too big. That was an M8. And then we have the M6. That fits just fine. Excellent. Excellent. And I think the next step is to give this a nicer shape and weld it proper. Weld it properly.
Grind the groove, weld the groove. Grind down the weld, reposition. Grind the groove, weld the groove. Grind down the weld, reposition. Repeat until fully welded. Then cut shape, grind shape, cut the groove, and repeat again until fully welded. Use the sanding disc to make it prettier. Then it's time for the nuts. Grind away the hexagonal shape where we do not need it, because obsession. Touch up the devices formerly known as nuts on the sanding disc. When all this is done, start preparing for welding. Align, clamp, measure, align, realign, clamp, double check, triple check. Are we done?
This is how I've clamped it. The threaded bar is resting on the same height pieces of steel at both ends, so it should be parallel with the table. I then have the nuts that will be part of the lifting mechanism threaded onto the bar. There's a gap between here, which is fine because I'll fill it in a little bit. And then I have clamped the eyelet to the nuts just gently, and then I have put shims underneath here to make sure that the eyelet is parallel with the table, which is parallel with the bar. That way it won't sit wonkily there. So now with just a bit of gravity and pushing, then that should stay there, which now allows me to put weld in here.
Oh, here we go again. I have a feeling of déjà vu. When welding the chassis tab, I'm trying once again to be careful with how much heat I put into the workpiece, and I try to let it cool down between the welds. I clean the welds up in between so that I get the cleanest welds I can. I also rotate the threaded bar between the welds so that I can get the heat to spread even more, but also so that the bar doesn't get jammed in one place. But of course, it still started binding. Not too bad, but too much for it all to run smoothly.
This is the result after blasting it with the hot glue gun for quite a while. I'm not going to hold it because it's still hot. So now I'm going to give it a bit of shape and hopefully it'll look really pretty.
Even if I'm not really a fan of the dirty job of using the angle grinder to grind down the welds, I'm always surprised at how beautiful the end result can be. My philosophy when it comes to shaping pieces like this is that anything that's not needed will be cut off. I try to make transitions smooth and in general the whole thing nice to work with and look at. Sure, it takes a bit of extra time, but I think the pleasure of having a nice piece is worth it, even if the bath water starts rusting before I manage to get out.
After a bit of a grinding session, it now looks like this. But due to removing quite a lot of material here, I have cut a groove here. So I'm going to fill that with weld and then I'm going to do the other side. I don't want to cut them at the same time, so just in case. So I'm just going to fill that with weld, probably grind it down and then cut a groove on the other side and do the same. And then it's I think the shape is correct now, and I then want to make it a bit birdy after we got the right shape.
Now when the chassis tab has regained a bit of strength that it lost when I was shaping it, it's time to use the flap disc to give it a once over. I tend to make sure that every surface gets the flap disc treatment, and then I try to remove any sharp corners or angles, and I round or bevel the edges for that final touch.
Okay, boys and girls, seems like we won tonight. Here's the end result. This is now the chassis mount, and I'm pretty pleased with it. It's not perfect, you know, but I think it's good enough to be used as a tool that is used very occasionally on a Unimog. So yeah, I think it'll do well. So with this one done, now we need to do the cab mount, which is a little bit more complicated, but at least we're making good progress. So diggity boo. Now it's time to do the cab mount, and the first task in that is to weld this bolt onto the threaded rod. This obviously needs to be as straight as possible, otherwise there will be too much wobbliness and that is no good. Then the next thing is to make the plate that goes between the bearings and then the tab or eyelet that goes into the cab. So let's get on with doing the bolt to the threaded rod first. Sorry for the banging, I'm pretty cool, but I can't fix the weather. I have been trying to set this welding jig up, or the clamping up. The idea here is that if I clamp the nut and the bar together, and then because they're not exactly the same width and height, there's a bit of play here, and I have been looking for shims. I've been using washers, some copper plate that I found, stainless steel plates that I found, some aluminium plate that I found, and various other things that I have found and thought might work, and nothing works, and I've been just running around like a lunatic here trying to find the right thing. And then I took a short break and I remembered a tip I saw. You put whatever it is that you want to center in place and you push it to one side, and then you stack one side full of playing cards, and then you take half of those playing cards and move them to the other side. It's very simple if you know it. Now sadly I don't have any playing cards here because I lost them in a game, but I do have some regular cardboard and some scissors, so I'm just going to make some spacers. Hopefully they're accurate enough. It takes what you got. The card trick, or the cardboard trick, worked. I just stuffed enough on one side for it to not move about anymore, and then I made sure I had the half of them on the other side, and that works fine. And then I just added a few clamps to it. Hopefully this will now allow me to put a few tacks on the threaded bar and the bolt there, and hopefully it will be fairly central. Let's see how straight I managed to get that. I think that's within tolerance. And that means that the step 1 of the cab mount is almost done. I just need to grind down the welds so that I can use a spanner on here when I need to twist it from this end. Continuing on with the cab mount, I'm going to use the same offcut from the angle iron that I used previously for the chassis mount. Ta-da, 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 that one. I'm going to start making the tabs for that, and then I'll work my way down to the connection of the rod. I now have the two pieces cut. There's a hole drilled in them, and I've used the hole to align them together, and they seem to align pretty well. So now I'm going to use the hot metal gun and just tuck them together. Then I'm going to cut them off and drill the hole and shape it. And after that I'm going to do the groove and fill the groove with weld as I did with the other one. Now that we have a hole, and we've tested that the hole and the tab and the bolt fits on the cab, let's add some more welds and give it a little bit of a prettier shape. I've been sitting here for a while and trying to figure out all of these things, and as usual my brain starts running out of dimensions. You can see 2 dimensions, draw on a paper or something like that, but then you put a 3rd dimension in, and then things start moving, and there are motions and things like that, and my brain just goes like, nah, I can't think further than that. So I find it very useful to sit down and just look at things and try to clamp things up and figure things out. So the first thing I want to do is to create the plate that is sandwiched between the bearings in there. Because I want to be able to adjust these 2 bolts, nuts here, to adjust the tightness on the bearing, I want to be able to have this flat so I could come in with 2 spanners or something from one side, or socket and spanner. This is a huge nut, so I can't just leave space to get in there. I also don't have 2 30mm spanners, so I can't just use 2 spanners on there, which means that I want the plate to be detachable from the eyelet, from the tab. And to do that I obviously need to attach it somehow, and I have these M10 bolts here that I want to attach. And sometimes I forget that I also need to get a tool in there. So at the moment I'm sitting here, this is one of the widest tools that I have for this purpose. And if I put it there, then I can judge how much space I need between the bar and the threaded bar and the tool and the nut. And then I obviously want to make the connection nuts to the actual eyelet somehow. And at the moment I've got this setup clamped here where the eyelet is clamped on the sides there like that. So I'm now kind of trying to judge how would I attach these sort of plates, or the legs to the eyelet, and then these to the connection nuts. And I think to avoid making too many mistakes I'm going to create the plate first, but I won't drill out the holes in the plate for the side nuts. I'll do that later. I figure that it's okay to do that. So I'll drill out the 20mm hole, and then I'll sandwich it between the bearings, and then I'll leave it oversized so I can drill the holes later and shape it from there. I'll probably mark a place for the holes to go so that if everything works, I'll drill it and drill it there. And obviously this eyelet that is in here now, there, needs to be centered on the bolt for best performance. But yeah, let's try to get this organically to grow into what I wanted to do, but I think this might work. Or you can follow the drawing, that works too. Making the plate and drilling the hole and marking a preliminary location has definitely helped my brain reach next stage. Anyway, let's spin this around first. Yay. So if I put the extension nuts on the spots where I mark the holes, like so, I then tried to figure out how does this attach here somehow. Obviously not touching that. This bit will be cut off, so it's lower, but annoyingly this isn't wide enough to reach these ones or those ones, and I tried various parts that I have here spare, the cut-offs. This one I've been using that a lot, as you've seen, and then I thought, what could I use? Is there anything else I could use? Yes, there's the U-channel, and if I now place the U-channel here and I butt it up to the extension nut like so, I can now see that if I put this in the center, or even so, there's enough meat to bridge that. So the next thing I'm going to do is to cut these into 45mm long pieces, which will reach above the nut there, and I'll have 2 of them, and I believe that now we are getting to a good solution on this one. And I will drill out the holes too, because they are in a good spot. I have now tack welded the contraption together. Bolts are going through there, so the extension nuts are tack welded to the U profiles, which is tacked to the actual tab here, and if I spin it on here, it seems to spin quite true, which is pretty good. So now I'm going to check if it actually fits on the truck. Yes, it does fit, and the rod will obviously come through in the bottom there. You can see my finger sticking out maybe, and there's ample room for this to swing and move around. Obviously this plate is going to be cut down a bit, so I think I can fully weld this now. this is what we ended up with. I think it needs a little bit of shape. It's a little bit crude in this state, and obviously I need to hide my crappy welding. Oh no, that's the nicer side, you need to see that side. Get the angle grinder out, the rotary eraser, and let's shape it a little bit. After some quality time with the angle grinder and the flap disc and the cutting wheel and various other aggressive tools, it now looks like this. And I think I'm gonna have to leave it alone now. It's not perfect, but I guess it'll work on a Unimog. The next thing I want to do is that I want to be able to secure the nut on top of this rod, because this rod is going to be spinning and that eyelet's going to stay still. Should for some reason that nut come off, there is a chance that the cab could tilt forward. I would rather not that could happen. Now, in my enthusiasm, I cut this bolt short enough to just fit the two nuts, the adjuster nut and the squish nut on here. I forgot that I should have left a little bit extra on here so that I could have drilled a hole in there, and I could have put a bolt through that hole or a pin through that hole so that the nuts couldn't come off. I made this bit also just high enough so there is no space to do much under there. So I now need to assemble it and see exactly how much space I have and what solution I can come up with.
And just after I said that, I completely ignored it. It was only several days later, when I was vigorously exercising the rod in and out, that the squish nut fell off. And I had to admit that ignoring this particular issue would not make it go away. Still later than that, I finally need to actually deal with it. So here you can see me consulting the one who decides me. With a few grunts from me and a lot of patience from Crazy Kaz, it was decided that the path of least resistance would be to simply drill through the nut and rod and simply put a split pin in. Which you can see us doing up at the corner, because I completely forgot that I was recording a time lapse. Once we had the hole drilled, we needed to do nothing more than use a soft percussion persuader to bash the pin in and bend it to lock it. And here's a few photos of the result. Function and laziness before precision and elegance.
So here we have it fitted, and I think it's looking quite good. I think this one will work really well. There's a little bit of binding here for some reason. I do not know why. Could be some dirt in the bearing or something like that, but I'm sure that if we ignore it, it'll go away. This here is the chassis mount bar. To prevent the adjuster nut and the squish nut and the rest of the contraption falling off, I'm going to put a bolt at the end of it. Just an M6 or an M5, we'll see what it ends up being. But a bolt goes through the bar, and hopefully that will prevent any of the nuts falling off. So I've just set up the drill press here to do this drilling. One of the cool things with this drill is that I can adjust the reach of it like this, but then I can also turn it on the pillar, which is probably common to all the pillar drills. But anyway, so I've aimed the drill down here at the bar, and I've made it pretty level. So now I'm going to just drill it. I've now spent a little bit of time, and by a little bit I mean a lot, to free this up so that it runs well. It's probably now about 12.96% lighter due to all the metal that's been shed. The next step, not the computer, but what we need to do next is to put this nut onto the rod there and then bzz, bzz, bzz it into place, and put a bearing on there, and put this onto there, and put another bearing onto there, and then put another nut onto there, and then squish that nut onto there, and then put the bolt through here, and then this rod is done. It's all ready for welding now. So nut, bearing under the tape here, just don't want weld spatter on it, maybe this will help a bit, and then the thingy, and then a bearing, adjuster nut, lock nut, and bolt through rod thingy. I'm just gonna give it 2 big tacks here. In case I need to take it off, I don't want to discard the whole threaded rod. So it's only there so that I don't have to put another squish nut on or drill through the threaded bar. Next up, bzz, bzz, bzz. Exciting. With the nut bzz, bzzed in there, it's now time to put this rod into these holes here.
It might not be clear from the plans, but this design requires there to be a nut on both ends. This is so that the end that has got the 24mm bolt on it can be threaded through either the connector piece or the chassis tab. Once the 24mm head is poking through, you can use your power tools. I should also point out that due to the binding, the 280-ish Nm impact driver was not strong enough. The 1000-ish Nm one worked a lot better, and it saved me a lot of effort. To reduce the binding, I'm skimming the tops of the threaded bars with the flap disc. I'm trying to do this as evenly as possible. This removes just a tiny bit of material and doesn't impact the strength at all. However, it does make a bit of extra room where the nasty zinc has been gathering. Then it was time to do something about that tube that I cut up earlier and put some strength back into the connector piece. I started by grinding down the welds to make a spot for the reinforcement bar. Then I decided to remove a little bit of material from the tube and tidy up that as well. I then shaped the reinforcement bar a bit so that it fits better.
You remember us fixing the binding with by cutting the slits into this upper tube, currently upper tube, and it made things better. I have since then run this threaded bar in and out of these 2 nuts way more times than I want to think about. Luckily, I've been aided by electronickery and an impact gun that is powered by Angry Pixies. It's worked quite well so far, however, this is going to get worse. You see, I hate binding a lot now. If I leave it like this force going that way and this force going that way is going to mean that these 2 end nuts here are only held on by these end plates. That means that there's 10mm on each side that is going to have to resist the forces. That in turn means that these ones might actually flex. And they will not flex in a parallel way, they will flex bending. Bending means, you got it, binding. So, to counteract binding, I would like to weld on this piece of metal bar here. However, welding causes distortion, and distortion causes binding. The immortal words of Bart Simpson, damned if you do, damned if you don't. To counteract the binding from the welding, I am hoping that by welding one end on first with the other one loose, I can let it cool down, and then I can weld this bit on here. Then finally I want to weld this bar onto the tube here, so that there would be a triangulation situation going from one to the other, hopefully eliminating the racking like that. However, every piece of welding causes distortion, which causes binding, which I then need to fix. With a little bit of luck, all I have to do is just, now be careful when someone uses the word just when it comes to doing things. It never is just. Just need to fix the binding, i.e. run the bar back and forth a long time and trying to get it to work. As you can see, I used a hot metal glue gun to stick the bar onto here. I also put 2 welds on each side there, so hopefully now this should be fairly sturdy. But what is absolutely unbelievable at the moment, it's completely blowing my mind, is this. There is a bit of binding, and that is every half turn. So this is free, and then it kind of binds a little bit over there. So to me that tells me that the rod is either a little bit bent, or there's that dreaded zinc coating on it that still needs wearing off a little bit. If I put little tiny on it here, it'll go like this. Keep in mind it's still quite warm from the welding, so it might ease up a little bit more than that, but I think I'll run the Ooga Dooga machine a few times through it and see if it just gets a little bit warm in the clothes. But to have it this is just, I thought I would just have to spend hours on this. So, ooh, almost cold snack time just because of this. There were moments when I thought this would never work. Disclaimer, it hasn't worked in practice yet, just in this sterile laboratory situation. But everything seems to be okay now. This doesn't bind, this doesn't bind, this doesn't bind, and this doesn't bind. So there's a good chance that it might actually work. Let me explain the components and how it is supposed to work. You're already familiar with the M30 threaded bars. Let's call this centerpiece the connector piece. The two nuts that are no nuts anymore are welded here. This is just a tube. On the top bar, which is the one that attaches to the chassis, we have the two nuts inside this one and the tab and ear that goes on the chassis. They rotate here. We have the welded nut here and an axial deep groove bearing here and an axial deep groove bearing here, an adjuster nut and a squish nut and an M6 bolt through the end here. That should hopefully prevent this one from just skedaddling off into the distance. Over at the ends of the bars there's an M20 nut welded onto the bar. The head size is 24 millimeters. When you turn this rod, this moves, this doesn't. When you turn this rod, this pushes this one away. On the cab mount bar, there's an M20 bolt welded to the bar, and then there's another deep axial groove bearing here, and a plate, and another axial groove bearing here, adjuster nut and a squish nut, and this one actually has got a split pin just drilled through it here to prevent it from coming off. It did actually come off once during the laboratory testings, so it is needed. There are two bolts here that are attaching the actual eyelet onto the plate. Those are the main components. It doesn't sound very complicated, and frankly it isn't very complicated. It's just that these threaded bars were not very suitable for this job. Anyway, that's the short of the operation and the functionality of it. Let's hope it actually chooches well on the truck.
Because I'm a bit of a numbers head, I wanted to work out how much all this has cost us. Even though we've used quite a few nuts and bolts, they haven't formed significant cost. These M30 nuts are £1.50 each, and this M20 nut and bolt assembly is £1. The significant cost has come from the 2 metre lengths of this M30 threaded bar, and that came to £34. The other significant cost has come from the 4 thrust bearings that we've used. They were £28. So the grand total was £75, €90 or $105 US.
I think it's important to acknowledge the people who have contributed to this before I started it. This is by no means my invention, and I have not done this on my own. Thanks to all of the people who posted these sort of things on the internet, and especially to Kieran Greenan, who sent me this PDF drawing that I have used extensively. Thanks you also for sending me all the information that I wanted, answered all my queries, and sent me the videos. That's helped a tremendous amount. I then took my fabric cobbling and I got my crayons out and I made this drawing.
I doubt you would understand what I've written here. Luckily, I was able to convey that to my friend P. David Storm, who is an excellent artist. Check out his stuff on Instagram. It is absolutely beautiful. He then managed to make this absolutely gorgeous PDF with my addendums on it. Thank you ever so much to both of you. Both of these PDFs will be linked in the description down below. Have a look at them if you want to build it, or just go admire P. David Storm's amazing artwork. And if you want to, give them a shout out in the comments to know that their effort has been appreciated. With the tilt mechanism now built and tested in the laboratory, it's time to scrap the plans and put it to its actual test and see if it works. But you're going to have to wait till the next episode. Congratulations, you've made it to the end of this mammoth episode. Well done! Do you think the cab tilt mechanism is going to work? Is it going to work well? Will we have enough power to turn the rods? Or is it going to fail? If we get the cab tilted, what else will we have to do? Put your predictions in the comments, and I hope to see you in the next episode. You want to play Unimog? Say hello to my little friend!